All right, everybody, welcome back. This is Math 025 for Hartford Community College, and this is Polynomial Factoring Part 2. In this section, we're going to start off by looking at factoring by grouping. And factoring by grouping is a technique that we will use when we have 4 terms. So when you're factoring, and after you've looked for GCF that you can pull out of all 4 terms, or all of your terms that are present, next, you're going to figure out, well, how can I factor this problem? If there are 4 terms, we're going to try factoring by grouping. And to factor by grouping, what you need to do is you're going to create 2 binomials by grouping 2 terms together. And then what you're going to do is you're going to pull a greatest common factor out of each of those 2 binomials, so the 2 terms that we've put together. And then we're going to see if we can factor that again. So if you look here, we have 4x cubed minus 2x squared plus 14x minus 7. And if I look at all of this right now, there's no greatest common factor that I can pull out of all 4 terms. But if I group it and I make it so that I have 2 groups, one 4x cubed minus 2x squared, the other 14x minus 7, I can pull a GCF out of each of these binomials. So I factored out 2x squared from the first term, and that left me with 2x squared from the first binomial, left me with 2x squared times 2x minus 1. And then from the second binomial, I factored out a 7. So again, it left me with 2x minus 7. And if we look at this, just like we did in that last video, now I have another common factor of 2x minus 1. So if I pull that out, and then I put my remainders over here, that's how I finish factoring by grouping. And we're going to take a look at that on the next few slides. All right, so here again, I have for A, I have 2 problems here. For A, I have 4 factors, x to the 4th plus 2x cubed plus 5x plus 10. However, if you notice, I don't have a greatest common factor that I can pull out of all 4 terms at once. So I'm going to look at and try to factor it by grouping. I'm going to group all of my first 2 terms together and then my second 2 terms together. Now, if I look at x to the 4th plus 2x cubed, I do have a greatest common factor that I can pull out here, and that would be x cubed. Because they both have x's, we'll take the smallest power. So when I factor that, I'm going to end up with x cubed times x plus 2. Because again, those x cubes right there make a 1. I'll keep that plus sign right there. Now, my greatest common factor for 5x plus 10 is going to be a 5. So when I factor that out, I'm going to end up with, I'll keep the 5 on the outside, and then x plus 2 on the inside. So now if we notice, I have 2 terms here, x cubed times the quantity of x plus 2, plus 5 times the quantity of x plus 2. I have another greatest common factor. This time my greatest common factor is my expression x plus 2. So I'm going to pull that out. And again, you don't throw away your GCF. You got to write it on the outside. So I'll have my x plus 2. And then when I factor it out on the first one, I'm left with x cubed. And then on the second term, plus 5. So that's my final answer there. I have x plus 2 times x cubed plus 5. We're going to do the same thing here. We're going to factor by grouping. So I'm going to put my parentheses around this. And notice here, like with all of ours, our leading coefficients right now are positive. So we're pulling out a positive GCF. Later on, we'll see somewhere there's not the case, and I'll show you what to do. And that's, again, you're leading the first coefficient, or the first in the first term. So my greatest common factor for 16x cubed minus 28x squared. I'm going to have to say 4 is my greatest common factor, and that would be x squared. So I'm going to pull out a 4x squared here. So that will give me 4x squared times 4x minus 4 goes into 28 7 times. X squared will cancel or equal a 1. Fix that for us. Okay. Plus 12x and 21. I think my greatest common factor there is going to be a 3. So that will be my 3 on the outside. 12x divided by 3 is 4x. 21 divided by 3 is 7. And again, I have 2 terms here, but I have a common term of 4x minus 7. So I'm going to factor one more time, and I'm going to factor out the 4x minus 7. And that will leave me with a final answer of 4x minus 7 times 4x squared, because that's what I get when I cancel out there, plus, or I factor out, 3. And that is my final answer for that one. All right, so next we are going to look at C, and we're going to start off again with 4 terms. I don't have a greatest common factor in all 4 terms, so I am going to factor them by grouping. So I'm going to group the first 2 together and then the second 2. For the first one, my GCF will be a 6. So that is going to, I'll put my 6 on the outside. It'll leave me with x minus 7 plus my greatest common factor here looks like it's going to be 5y squared. So I'm going to put my 5y squared on the outside, and then I will be left with x for the first term minus 7. And if you notice here, again, I have in each term a factor that is alike. It's the expression x minus 7. So I'm going to divide everything by x minus 7, or both terms by x minus 7. And my final answer then will be x minus 7, because you don't want to throw away the GCF, you got to write it out there, times 6 plus, which came from here, 5y squared. Now for D, I'm going to group my 2 terms. The first one is normal. We have 9x cubed minus 3x squared. But the second set, you'll notice we have that negative there. Remember when we factored out the negative 1 earlier, I said your leading coefficient in your groupings, you really want it to be positive. Whenever the first coefficient in a term, or the coefficient in your first term of a grouping is negative, you want to pull out a negative greatest common factor. So for the first 2, my GCF would be 3x squared. So I would have my 3x squared here. And then it's going to, 9 divided by 3 is 3. X cubed divided by x squared is x. And then we have our 3x squared here. This 3x squared divided by 3x squared, they're both the same, so it's going to equal a 1. We don't just put nothing there. We don't say it cancels. We have to keep that 1. It equals a 1. Now, for 15x plus 5, because it's a negative 15, my GCF is going to be negative. So I'm going to pull out a negative 5 here. That's my greatest common factor of 5. So I'll put my negative 5 there. And 2 negatives. Negative 15x divided by negative 5 will give me a positive 3x. And then positive 5 divided by negative 5 will give me a negative 1. And notice, by pulling out that negative, I also created 2 common factors there. So now I'm going to factor out of each of these my GCF, which is 3x minus 1, So my final answer will be 3x minus 1 times, I'm left with 3x squared minus 5. Right, now for E, again, we have 4 terms, but no greatest common factor amongst all 4 of them. So I am going to group it. Notice I have that negative 5a, so whatever I pull out, it's going to be a negative GCF. For the first 2 terms, 5 and 4, my GCF is 1. We have a squared and a, though, so I can pull out an a. I'm going to factor out an a here, so I'm going to put my a there. 5a squared divided by a is 5a, plus 4ab divided by a will give me 4b. Now, with the second pair, 5a and 4b, the only greatest common factor I have is a 1. But I can factor out, again, I have to factor out that negative 1. So I'm going to put my negative 1 here. And I'm going to factor out a negative 1. So you can, if your GCF is 1, factor it out, which really just means putting a 1 on the outside of the parentheses. Here we had to do a negative 1. 2 negatives make that a positive 5a. 2 negatives there make that a positive 4b, which is nice because if I look, now again, I have a common factor here. So I'm going to factor out now 5a plus 4b, and again, don't throw it away. So my leftovers, as I call them, or what is left when I factor out the common factor, is going to be a, and then over here will be a negative 1. So there's my final answer there. Now let's take a look at F. Again, we're going to factor by grouping. Negative 15, so I'm going to have a negative GCF to pull out. For 6x squared y minus 4xy, my GCF is going to be 2xy. So I'll have 2xy, and that's going to leave me with 3x minus 2. Up here, I'm going to pull out a negative 5a because I need a negative because my leading coefficient was a negative. So that's going to give me negative 3x, or excuse me, I need to put my negative 5a right there first. Hold on one second. Let me put my negative 5a times, and then I'm going to have a positive 3x. And then 10a divided by negative 5a will give me a negative 2. I'm going to factor it again. One more time, I got that common factor of 3x minus 2. So, put my GCF here, my 3x minus 2, never throw it away. Factor that out, so I'm left with in the other term 2xy minus 5a. And that is it for factoring by grouping. All right, so next we are going to look at how to factor trinomials. So these are polynomials with 3 terms. And we're going to start off with what they call the easy trinomial. It is considered an easy trinomial because the x squared term, or the first term, is only a variable, does not have a coefficient other than 1 in front of it. And to factor an easy trinomial, what you are going to do is when you factor a trinomial, if it's factorable, typically it will factor into 2 binomials. And what we want to do is, remember, your trinomial is in the form of x squared plus bx plus c. Well, what you are going to do is you're going to look at your c term, your constant term, I want you to figure out what two numbers, like what are the factors you can multiply to get C, but that will also add to give you that middle coefficient of B. So here, they have factored this trinomial 2x cubed plus 14x squared plus 20x. Now you may say that doesn't look like an easy trinomial. First thing you always do is factor out your GCF. You always have to look for that GCF. It's one of the steps we tend to forget. So they factored out the 2x. We got that GCF out. Now they are just factoring x squared plus 7x plus 10. All right, here is my B term and here's my C term. So I'm going to start with C, 10. To get 10, I know I can do 1 and 10 or 2 and 5. Now I need to find a combination of those two that will also allow me to add to 7. 1 and 10, if I add it, it's not going to give me 7, but 2 and 5 will. So now when I go to factor my x squared plus 7x plus 10, my first terms in each binomial will be x. Because again, remember if you FOIL, x times x will give you x squared. But my 2 and my 5 are going to go in the other part. And it's going to be 2 plus signs because I have 2 plus signs here. Then we'll get that 10. Let me erase this so you can kind of see it a little bit better. So this is 2 and this was 5. When I FOIL this in my middle terms, my O and my I would have 2x plus 5x, which would add to give me 7x. And then my last two terms, when I multiply those, 2 times 5 would give me my 10. Okay, so the final, if I factor x squared plus 7x plus 10, the factored form is x plus 2 times x plus 5. And again, that was found by looking at the factors of C that would also add to give me that B coefficient. All right, so we are going to, again, factor the easy trinomials. And again, it's easy because there's a 1 in front of that x squared term. So first we have x squared plus 5x plus 6. So I'm just going to start off and draw my two binomials. I'm going to start off by putting my x and my x in the first part. Now for this one, because I have 2 plus signs in my trinomial, when I factor it, I will have 2 plus signs as well. So I'm going to add those in. Now I need to know, for 6, I can multiply together 1 and 6 or 2 and 3. Which of those pairs of factors will also add to give me 5? Hopefully you're looking at that and you're saying, well, it's going to be 2 and 3. So yes, and it doesn't matter what I put where. Like I could put the 2 first or the 3 first, doesn't matter. But my final factored form there is x plus 2 times x plus 3. For B, again, always look for a greatest common factor, but with these easy trinomials, most of the time, if it starts off with x squared or a squared, I don't see, there's not a greatest common factor there. So I do, instead of x, this time have a. So I'll put my a's first. Again, I have 2 plus signs, so I'm going to put both plus signs in there. Now my C is 36. So my factors of 36. We have 1 and 36. We have 3 and 12. We have 2 and 18 and 4 and 9. And then I believe that is it. Now I need my pairs of factors to add up to 20. So 1 and 36 does not add to 20. 3 and 12 does not. 4 and 9 does not, but 2 plus 18 would give me 20. So 2 and 18. And there we go. That is our factored form. All right, next we're going to take a look at C. And this time we're dealing with b squared minus 4b minus 12. So there is no greatest common factor here. So I don't have to factor out a GCF. But I am going to factor this I'll make my two binomials. I'll put my b and my b. Now this time I have two minus signs. But when we factor it, we are not going to have two minus signs in our binomials. So let's take a look at what we can multiply together to get 12. Or if it helps you to think, like, what can we get to get a negative 12? Now, first I'm just going to focus on the 12. I know to get 12, I can multiply 1 and 12, 2 and 6, or 3 and 4. But I know I also need a combination of these two to give me a negative 4. So I'm first going to look for any combinations that could give me a negative 4. And in this case, 1 and 12, if I do 12 minus 1, I get 11. If I add it, I get 13. I know it will not work. 3 and 4, if I subtract the 2, I get 1 or negative 1. Not going to work. But 2 and 6, I know I can get 4 from it. Now, I need a negative 4, and when I multiply, I need a negative 12. So remember, when we multiply, you're going to have one positive number and one negative number. So I'm going to start off, and I'm going to say, okay, well, if I make the 2 a negative and the 6 a positive, that gives me negative 12. But if I add negative 2 plus 6, if I did negative 2 plus a positive 6, it gives me a positive 4. I need a negative 4. So swap them around. Do negative 6 plus positive 2, and that gives you a negative 4. And negative 6 times 2 also gives you negative 12. So here, if I have two minus signs, I want you to think about it. If you have two minus signs, your two signs in your binomials are going to be one positive and one negative. And in this case, I know I need a negative 6, so I'll do b minus 6 and b plus 2. And that is my factored form for C. All right, now let's look at D. Y squared plus y minus 42. Again, no GCF. I have two different signs, so because I don't have two plus signs, I do need to look at those signs. I know C needs to be 42, and it also needs to be negative. So for 42, I know I can do 1 and 42. I can do 2 and 21. I can do 3 and 14. And then 6 and 7. Now, I need a positive 1 here. 1 and 42 isn't going to give it to me. 2 and 21, 3 and 14, but 6 and 7. Now, if I add them together, I get 13. That's not going to work. But I know this 42 really needs to be negative, so I want one positive number, one negative number. I need a positive 1. So if I make 6 negative and 7 positive, if I just practice this, negative 6 plus positive 7 will equal a positive 1. So my two factors would be a negative 6 and a positive 7. And, you know, the better you are at your multiplication facts, if you're not very good at them, I encourage you to practice them and learn them again, because the better you are, the quicker this goes, and you don't have to sit here and write all these out or use a calculator to help you find those factors. They will come to you pretty quickly, as long as the numbers are fairly small, and we try to keep them that way for you guys. Okay, so now here we're looking at E. We have z squared minus 14z plus 33. So there's no GCF to pull out, so I know I'm going to have a z and a z. Now I need to make 33. I need a positive 33. So let's see, we need 1 and 33, but I do need a negative middle term. And then 3 and 11. Now the only way to get 14 would be to do your 3 and your 11. But I need a positive 33. So that means my last two terms, or what I multiply together, have to be two positive numbers, or two negative numbers, because remember, two negatives gives you a positive 33. But if I add negative 3 plus negative 11, it also gives me negative 14. So my two answers here, if you have a negative and a positive in that order on your trinomial, when you factor it, if it's factorable, your two signs will both be negative. Again, it doesn't matter the order. I'll put my 3 and my 11 here, but if you swap it around, it's fine. Let's take a look at F. Again, we have a negative and a positive in that order. So I should have two negative numbers when I factor. And I'll put my P's in there. 63 is our factor. We need to look for the factors of it. So we have 1 and 63. It is not divisible by 2. But we have 3 and 21. 63 divided by 6 now. Oh, it is 6 or 7 and 9. 63. I'm thinking about my math facts there. I'm messing them up. Okay. So 63 divided by 9, 7 and 9. And we need a negative 16. So I know 1 and 63 won't work. I know 3 and 21 won't work. But 7 and 9 will, as long as I make them both negative, because negative 7 plus negative 9 will give me negative 16. And it will multiply to give me positive 63. So there it is factored. Okay, let's take a look at G. Now, the first thing you see when you look at this is, oh, whoa, whoa, whoa. It does not look like the other ones. It has a 2 in front of the x squared. It has a y. But again, first look for your GCF. Is there a greatest common factor I can pull out of this problem? Hopefully you're looking at this and you're like, oh yes, they all have a y and they have a GCF of 2 for the numbers. So we can pull out a 2y. So if I factor out a 2y, you can't remember throw it away. So you got to put it on the outside there. And the 2's will equal a 1, the y's will equal a 1. So I'm left with x squared plus 9x. So the y's equal a 1. 18 divided by 2 is 9. Plus 20. Now, we factored out GCF, but we do need to see, can we factor this trinomial? And we have a 20 here, so we have 20, which is 1 and 20, 2 and 10, or 4 and 5. I need it to add to 9, so I'm going to use 4 and 5. So my final answer here is we have that GCF we pulled out, the 2y. You got to leave it there. And then it's going to become x plus 4 times x plus 5. So it looked really hard, but once we got rid of that GCF, made it nice and easy. Same thing with H. If we take a look here at H, is there a greatest common factor we can pull out? There definitely is. We can pull out a 3t. So I'm going to factor out a 3t. So when I do that, I'll leave it out here on the outside, and it's going to leave me with t squared plus 4t minus 12. And then we got to factor the trinomial if we can. And I have a plus and a minus in that order. So if you have a plus and then a minus, that second term needs to be negative, that's C term. So I'm going to have one positive and one negative. Again, let's look at 12. We know we can do 1 and 12, 2 and 6, 2 and 6, or 3 and 4. But I need a positive 4 there. So 1 and 12 and 3 and 4 aren't going to work. It needs to be a negative 12. So I need one negative number. And we're going to do negative 2, because I remember from earlier, negative 2 plus positive 6 will give me a positive 4. So there's our final answer. Okay, we have our next two examples here. We are going to look at, first, for the first one, definitely pulling out a greatest common factor. And my GCF here looks like it will be 9b squared and when I do that, let's see, 162 divided by 9, just double check. Yep, 18. Okay. So this is going to leave me with, when I factor that, I'm going to have 9b squared on the outside, a squared on the inside, because that'll equal a 1, minus 3a minus 18. And now we want to factor that inside, so I'm going to keep my 9b squared. It doesn't go away. We have to keep it on there. And we'll have a and a. Now we need a negative 18 and a negative 3. So negative 18, or just 18, is 1 and 18, 2 and 9, or 3 and 6. But I need a 3, so I can only use 3 and 6. I'm going to have two different signs. I'm going to have, because I need a negative 18, so one positive, one negative. So I'm going to make the 6 negative and the 3 positive, because that negative 6 plus 3 will give me negative 3. And there's my final answer there. Now for J, you're looking at that and you're like, okay, it looks great, except for we have 3xy and 2y squared. So we have x squared and y squared. They're like bookends, and they're squared. It is still factorable. There is no greatest common factor here. When we go to factor this, we definitely will have x times x in my first two spots, because that'll give us x squared. But because we need that y squared on the end, right here, whatever numbers we fill in, we're going to have a y with it, because the last two terms will give me y squared. And then when we multiply in those middle terms, it'll give me xy. Now, and I'm going to rewrite this so it's a little easier to see. We have two plus signs, so it's going to be plus. And I know I need a number there, so I'm going to leave a little line. The only way to get 2 is to do 1 times 2. It has to add to 3, which luckily 1 plus 2 equals 3. So we're going to have a 2 there and a 1 there. Now, you don't have to put the 1 there. You can just rewrite it as x plus 2y times x plus y. We don't have to put the 1 there. But again, my factors of 2 are 1 and 2. It had to add to 3, and we had two plus signs. So there's our factored form there. All right, so these are our last two easy trinomials before we get into perfect square trinomials and hard trinomials and some other things in the third video. We're going to try another one where we have a squared term in the first term and that second term. So we have p squared minus 10pq plus 16q squared. So again, when I go to factor this, there's no greatest common factor, but I know I need to have p times p, so p in each of the first two terms. And on the second parts, I need a q for each, so I can have my q squared. But now I need to figure out signs and numbers for the coefficients for the q. So let's see, 16, in order to get 16, we can do 1 and 16, 2 and 8, or 4 and 4. And I need to make a 10. So the only way I can get a 10 is my 2 and my 8. It needs to be a negative 10, so I have to have negative 2 plus negative 8. So negative 2q and negative 10q. And again, remember when we said when you have a minus and a plus in that order, when the minus comes first and then the plus, your two signs will always be negative in your two binomials. And then our last one here, we have L. Now, L doesn't have a variable on each end, but we have k to the fourth power plus 6k squared plus 8. Normally we'd say, okay, we can pull out a GCF and get it down to a squared term, but that's not the case here. However, this is still factorable because, remember, what can we multiply together twice that will give me k to the fourth power? Hopefully you're like, well, I know that k squared will, because if I do k squared times k squared, remember we add our exponents, so that would give me k to the fourth power. And then now I need to figure out that 8. I can do either 1 and 8 or 2 and 4, and I need to make a positive 6. We're going to use our plus 2 and plus 4. So don't let, as long as the power is even here in your factoring, you can split it up. Don't let it scare you. That's it for easy trinomials and factoring by grouping. I encourage you guys to practice those quite a bit, get really good at those before you start video 3, which can be a little bit harder. We're going to look at hard trinomials. And again, knowing those multiplication facts, I can't emphasize enough how much that will help you. Bust out a multiplication chart, practice it, do some flashcards. I know it sounds silly, but it will help you out tremendously with factoring and then just going further in math. It'll help you out a great deal. Have a great day.